Okay, so the purpose of this video is to explain how to solve a system of three equations that has infinitely many solutions. And when I say solve, I mean write a rule for all of the solutions of this system. So I'm going to use matrices to do this because I'm in the midst of a matrix chapter. And what you'll notice is that there's only two equations, but there are three variables. And that brings us to one of our first rules about systems of equations. In order to have just one solution, a system of equations would need to have the same number of equations as variables. So anything that does not meet that same number of equations as variables is going to be a weird system, one of our special cases. In this case, we've got more variables than equations, and that always implies that there are infinitely many possible solutions. So I've got three variables, only two equations, infinitely many solutions. So what we're going to try to do is write a rule for what those solutions are. And it's not all real numbers or all real triplets. There's infinitely many solutions, but not everything is a solution to this system. So first, since I'm in the matrix chapter, I'm going to write this system as a matrix. Notice I made the third row of the matrix all zeros, which is equivalent to saying infinitely many solutions. I just need to get to the part where I write a rule. So in order to get to that point, I'm going to need to eliminate at least one of the variables, either one of the x's or one of the y's. And if I do that, then I can write a rule for my system. So I look at these four options, the x's and the y's, and try and decide which one's going to be easiest to eliminate using row operations. The easiest one is going to be the 2 in row 2. To eliminate this 2 in row 2, I'm going to multiply row 1 by negative 2 and then add it. So I redraw my matrix. Row 1 is not changing. Row 3 is not changing. But row 2 is going to change. So I'm going to take the values from row 1, multiply by negative 2, so 1 times negative 2 is negative 2, and then add it, so 0. Then I go to negative 2 times negative 2 is 4, plus 3 is 7. And then 2 times negative 2 is negative 4, plus negative 1 is negative 5. And finally, negative 2 times negative 2 is 4, plus 1 is 5. All right, now that I've eliminated one of the variables, I can rewrite this out of matrix form. So my two equations that I have now are this first equation, which would be 1x minus 2y plus 2z equals negative 2. And of course, I don't actually need to write the 1 in front. So just x minus 2y plus 2z is negative 2. And my second equation would be 7y, because it goes x, y, z. So 7y minus 5z equals 5. You take these two equations and you solve one of them for x and one of them for y. So I'm going to solve this first one for x. I would get x is equal to 2y minus 2z minus 2. And over here I would get 7y equals 5z plus 5. Dividing by 7, I get y equals 5/7 z plus 5/7. So now I've got x, I've got y. Y is only in terms of one variable, but x is in terms of two different variables, which is considered poor formatting. I need to replace this y then with what I know y equals. So according to my equation over here, I've got y equals 5/7 z plus 5/7. So I'm going to plug that in. Instead of y, I write out that expression. So distribute to get 10/7 z plus 10/7 minus 2z minus 2. We'll need to combine like terms, and in order to combine things, one fraction, one not, I need to get the common denominator. So negative 2 is the same as negative 14 over 7. Okay, combine like terms, and I get x equals negative 4 over 7z minus 4 over 7. Now I've got an expression for x, I've got an expression for y, and then you've also got z is just z. The best way to format this is to get all of your expressions, x, y, and z, in terms of some other random variable. The variable that my textbook uses is t. So instead of z, I'm just going to write t. So I'm writing an ordered triplet, x, y, and z. Instead of x, though, I'm going to write -4/7 t minus 4/7. It doesn't have to be t. You could technically leave it z, it would still be equivalent, but we're just going to be consistent with our textbook and use the variable t every time. Then y, on the other hand, would be 5/7 t plus 5/7, and then z is just going to be t because I replaced all of the z's with t, so z is t. All right, this is considered the rule for all of the solutions, so this would be your answer. If you were answering a question like this on a test or quiz, that is what would get you points. I want to go a little bit further than this, past the answer, just to show you what this rule tells you, because this is a rule that tells you all of the solutions of a system. It tells you how to generate solutions. So t can be anything. I'm going to pick everyone's favorite number, 1. Let t be 1, and you can find a solution to the system. So if t was 1, x would be -4/7 times 1 would be -4/7 minus 4/7. So x would be -8/7. Y would be, plug in 1 for t, you would get 5/7 plus 5/7, so you would get 10/7. And then t is just 1, so that's z. So I can say that this ordered triplet is a solution to the system. Something that is not plugged in properly would not be a solution. So let's say I want to test if something is a solution. So let's try the point 2, 1, 0. Is it a solution? To test it, you have to know that this is x, y, z, and so we're letting t be 0. If this is a solution, then t is 0. Plug it in for y and make sure we have the right y. Y would be 5/7 times 0 plus 5/7, which is just 5/7. And right away I can see that this is not going to be a solution because the y would need to be 5/7, but instead it's 1. So let's try one more. Or let's get the x actually. So to get the x, it would be -4/7 times 0 minus 4/7, which is -4/7. So this is a solution, -4/7, 5/7, 0. This thing is not a solution. So we can try one more. Let's see if 4/7, 5/2, and 1 is a solution. So if this is a solution, then we're letting t equal 1. So if t is 1, then y would have to be, according to our equation, where we write our equation up here, 5/7 t plus 5/7. So it would need to be 5/7 times 1 plus 5/7. That gives you 10/7. Our y, however, is 5/2. 10/7 is not the same as 5/2. So once again, no, this is not a solution. And you could test any other point, or you could generate any point that is a solution of this system by just using the values for t. And that is what you would have to do. So our goal is to get here. This stuff down here is just extra how to tell if it's a solution, if a certain point is a solution using that rule. So we just need to get the rule.